Hello everyone, we're looking at example 9 on page 525 from your textbook. Now we're going to start graphing cosine functions and sine functions that are given to us with some transformations in there. Okay, so example 9 says sketch the graph of y equals 3 cos 2x. So the first thing you want to be thinking about is going back to here and thinking about what does transformational form look like and what position are these numbers in as far as transformations go, and then how do we translate that into how I draw the graph. Okay, so we want to be thinking about this number right here. So this number is in the position of the vertical stretch or compression. This number is bigger than 1. Okay, so it's going to be a vertical stretch. And it's positive, so there's no reflection in the x-axis. Okay, so it's basically going to change the amplitude. Changes amplitude. Sorry about those yucky pieces on my flip chart paper again. They're just blemishes that I can't get rid of. Changes the amplitude from 1 to 3. Okay, so the amplitude is going to be 3. All right, second part, this number right here, it is in the B position, so it's going to be a horizontal stretch or compression, and we'll be able to tell the period of that based on this equation. So the period, I'll say this first, horizontal, is it going to be a stretch or compression? We'll talk about that in a moment. Stretch or compression, because I didn't talk about that in detail in the last video. Horizontal stretch or compression, we'll figure out which. Based on this equation, period equals 2 pi over b, which in this case is 2 pi over 2, which simplifies to pi. Okay, so the period is pi. So the period of the normal cosine function, just y equals cos x, is 2 pi. So that period over pi is over 2 pi is going to become half as big. It's going to be pi. So that's a horizontal compression. Okay. So remember, vertical stretch or compression sort of works the opposite way that a horizontal stretch or compression works. In this case, it's a horizontal compression. Okay, and notice that this number b was bigger than 1. Okay, so when that's a value bigger than 1, it's a horizontal compression. It means basically that for wherever there was 1 period before, there's going to be twice as many periods. It's going to be 2 periods in that same length of time. Or you can think of it as the period is shrinking. The period is now only pi instead of 2 pi. Okay, so it's a shorter length period. All right. If we look at our original function, one here, make this longer, put -1 here. Oh, I need more space than that. That's not going to work for a good scale, is it? Okay, because I need my to go to 3. Okay, so let's say 1, 2, 3, this scale, so -1, -2, -3. All right, now let's talk about the last transformations: horizontal translation, vertical translation. Vertical translation will actually always tell you what the principal axis is. And that's another important part. The principal axis will always be y equals d. So where is the principal axis here? Well, there is no d value out here, so the principal axis is still at the x-axis, y equals 0. Okay, so this is going to be the middle of the graph. Okay, now remember, y equals cosine x goes through its maximum at the y-axis unless there's a horizontal translation. Is there a horizontal translation? No. That means we must be going through the maximum at the y-axis then. All right, and I can be thinking about the principal axis being on the x-axis here, I can think about this as my principal axis. There's my maximum, okay? And my minimum then will be at -3. Okay, let's put some more x values. Put our x values on here. Whoops. Continue this. Okay, there's a good x scale across there. So, the y equals cosine x. Let's just lightly put that in here. That would be here, coming here. Down to here. Back up through there and here. So this is, because my scale, at y-axis scale is a lot different than in the last video, it kind of looks a little bit different, but same period, 2 pi, and same shape, went through the maximum at the y-axis here. All right, so we're graphing this one. I'll put it in red so we know it's the red graph. We can compare all of these major points to the points we need on here. So 3 is the maximum, -3 is the minimum, okay? Now, because it's at this maximum, it's actually going to go through this maximum again the next time it starts repeating itself. And since we know the period is pi, then from 0 to pi, we know it's going to go through a maximum again. And then it'll go through another maximum at 2 pi. Okay? Now, because of the shape of this y equals cosine graph, we can realize that halfway of the period, from 0 to 2 pi is a period, so from 0 to pi is the halfway point, and that's where it reached the minimum. So the minimum will occur halfway between the two maximums. Right? So the minimum will occur at pi over 2. Okay? Now, halfway in between the maximum and the minimum is where it will cross the principal axis. So it will cross the principal axis here and again here. All right, so that graph does this, and then it's going to repeat again. Halfway between the two maximums will be the minimum, and then halfway between the maximum and minimum will be where it crosses the principal axis, so in both of those places. And that is that graph. Put arrows on unless the domain is restricted. Let's see, was their domain restricted? Looking at the question. Yes, their domain is restricted. Okay, and I forgot to add that in here, so let's add it in. We need it to graph this from 0 to 2 pi. 0 less than or equal to x less than or equal to 2 pi. Okay, so we do not put an arrow there all the way to 2 pi, and we do not put an arrow there. Okay, there's example 9.